Hello, everybody. Today is going to be a doozy of a lecture on DynamoDB. And DynamoDB is probably one of my favorite services by far of anybody, really. Just the power that you have with Dynamo is kind of unlike a lot of other stuff. Um, and with just the modeling that you don't have to have compete or constantly have an open WebSocket. You don't really need to have any connection pooling, excuse me, like you would with a MySQL or Postgres or whatever, or even like a Mongo, another different NoSQL store. Um, it suits itself very much to serverless, and that's why it's a very good thing to just know about. And there's a lot of uh, patterns that lend themselves to other NoSQL solutions as well. So to review, what's a NoSQL database? There's a couple of them. There's document stores like Mongo, there's key value stores like Redis, and column stores um, like uh, wide columns is what this should be, like Cassandra. And again, Dynamo is kind of a mix of three. It's got wide column key value that supports documents. And we'll get into that, why that's actually kind of weirdly true. It's super marketing jargon, but it's actually pretty true. You want to have your data denormalized, and that means embedding objects inside of other objects. And in the Mongo or Cassandra way, that literally means like shoving them in the same document. And then, oh no, my document's over 16 megabytes. What do I do? With uh, with Dynamo, it's a little different. You can get away with not needing to necessarily use everything inside of an exact object, but you can embed them in a different way. And we'll get into that in the actual data modeling. And NoSQL databases are CPU optimized, not storage optimized. So you're going to be okay with duplicating data in order to minimize the thing in the data center that costs the most money right now, which is the CPU, because storage is dirt cheap. Again, review, why would you use NoSQL? You have known access patterns, and this flies in the face of so many um, early early thoughts about NoSQL. I don't want to call them naive, but they kind of are. That a lot of folks think about NoSQL as this super flexible data pattern that you can just kind of shove documents in willy-nilly. And while that's true, it's also couldn't be farther from the truth. NoSQL solutions are very tailored to your application. Like your data fits exactly the way your application works. They're easy to change the data, but they aren't the patterns that your application uses aren't. And so there's trade-offs to these. Um, NoSQL shines when you don't try to make like a faux SQL solution. You want to embrace having your data be a very quick lookup, and that's what NoSQL's all about because it's fast. And when it becomes not fast is when you've used the tool incorrectly. There's plenty of reasons to not use NoSQL solutions, but when you use them the way they're intended to be used, not just thinking of everything is a nail because the only tool you know how to use is a hammer, then it's not it's how you implement it, is what I should say. And NoSQL solutions are very good at online transaction processing. Just repeatable patterns uh, and that are common for your application. Um, Again, OLTP is what this kind of acronym is all about. So, what is Dynamo? Uh, it is a NoSQL uh, database again because there's no schema. Like the schema is not fixed, with a little caveat, but you don't need to have, say with I mean, everybody here has done a database class where you had to implement a SQL database. You don't have a schema where you need to make sure every single column is defined. So that's why it's just a NoSQL database. You do have to define table keys though. And so that's kind of a different piece that sets Dynamo kind of apart from others. The only thing you need in a Mongo uh, schema, for example, is an underscore ID. You just need to know what that needs to exist in order for the Mongo engine to work. But with Dynamo, you do have to define table keys. And so that can be a key value and a document store. I'm sorry, this is a key value and document store. All fields don't have to match on each document. So you can have very similar to NoSQL, just it's a, I mean, you can store one document that has, foo bar and another one that's, bar baz, whatever. You can store different documents that are, one is a user and one is for our example, one can be an album. There's no reason those can't be in the same table. There's no reason they can't be in adjacent rows, honestly. They can, the schema is not fixed. It's how you use that data. Now there are types in Dynamo. There are your standard uh, string, number, bool, and binary is just going to be your binary data. You can technically store like a PNG, a small um, PNG inside of Dynamo. It's not a fantastic idea, but you can just store binary data. Then there's sets. So sets are going to be of the same type. So Jen, Roy, and Moss are from the IT crowd, and they all have to be strings. And just these are just sets of numbers. I mean, it's there's some subtle performance gains you can use from, or you can gain from using sets within Dynamo, but um, they're outside the scope of this class. Then you can use documents. You can use a list, which is kind of your just standard JavaScript array that is, you can mix strings, you can mix booleans, you can mix numbers, doesn't matter. And then you can have a map, and a map is just going to be JSON data. You you can store, and this is a very big reason why Node is very common with using DynamoDB, just because it's very easy to store just a JSON object. Um, you can serialize and deserialize in and out, obviously, with JSON, but um, it just makes it very easy. But regardless, you can store a map in other languages as well. The Ruby, you can just have a to JSON, I think. Method, same thing with Python. It doesn't particularly matter, but it's just going to be an object for your map. Uh, DynamoDB is made of tables, and this is very very important. It's sort of a strange it's sort of a strange thing to think about where you have a NoSQL database, but it's made of tables. It's really just their internal naming for what these things are. But tables have items, and there is a consistency model to these tables. So eventually consistent, and these consistency models are very important. They're going to be, I mean, they're going to be on your final. But eventually consistent and strongly consistent are kind of core things to think about when you're using these services as well. So eventually consistent means that you're going to get I mean, it's very similar to the lecture on S3. Eventually consistent means you're going to get immediate um, immediate read after write. But what you can think about is that if you need your data in about a second, then you can use the eventual consistency model. Strongly consistent means that you need um, immediate consistency at all times. You need, I mean, you can think about this for maybe like games or for whatever other reason. IoT is very, very common with this. But you need immediate consistency always, especially if you're overriding anything. Then you would maybe consider strongly consistent. Uh, and these are at the table level, I should say. Tables have a hash and a partition key. And what this means is that the hash key is, and it used to be called a partition key, but the hash key is very similar to a hash table. Like you all have done your data structures class. There's a hash table. Like that's why it's called a hash key, is that uh, DynamoDB is very similar to a hash table, and we'll get into why that is a little more later. Uh, but tables have an optional range and sort key, and this is what makes that a wide column as opposed to just a key value. So you can actually not use a range key. You can only use a hash key, and these terms will get more concrete as in the upcoming code. Um, but with hash key, if you just got rid of a range key, and you could have just essentially Redis, like that's why it can be a key value store. Just using the hash key. Excuse me. But combined with a hash and a range, you get what um, you get what you call a composite key. And the composite key is very similar to, I mean, it's not unique to Dynamo, but it's where a lot of people understand their first use of a composite key. So it's with any real sharded database, um, you're going to need a composite key. And the composite key is going to be the combination of this key and this key. And the combination of these two have to be unique. If you're using a range key, you do not have to have a unique hash key. You can have a user of 1 and then a range key of 1. But you then can have a hash key of 1, and then you have to have another range key of 2. So it gets a little interesting. And this is how you can group large amounts of data together and not have to embed them in documents, like I was saying earlier. And again, it'll be more clear once you can watch some code with it. But these are important key concepts to cover before we get into code. DynamoDB indexes, in case you need a refresher, indexes are magical ways to speed up databases, but in a kind of slightly more technical way. SQL indexes allow you to perform fast queries on specific columns in a table, and NoSQL indexes can allow you to perform fast queries based on attributes of a document. For example, a Mongo index you can have an index on any attribute with caveats of a document. And SQL, you can think about it mostly as on specific column or columns if you have a multi-column index. Indexes in DynamoDB are very similar. You can have these terrible, evil things, like do not use these, but I'm going to go over what they are. There's local indexes. They are on the same table. And again, I said everything comes down to a table with Dynamo. They're in the same table because they have the same hash key, but they have a different sort key. So recall here that we have an optional range or sort key. I'm going to use these interchangeably. They have an optional range or sort key, and that is going to be, there's really, I'm just going to use this example of your hash key can be a user ID and the range key can be their email. So it's a very, very bad example because you don't ever want to have a hash key being unique and the user IDs are going to be unique. But for the sake of simplifying this to a mental model, we can discuss in this without any code. We'll say that the user ID is going to be your hash and the email is going to be the range. Again, please never use this, and we'll get into why, but it'll be a good common ground. So a local secondary index would be our our hash key is still the user ID, but now the sort key, we can have a different sort key of first name. Say we needed to get a user by their ID and their first name. That would be why you would use this local secondary index. Again, I hope this illustrates why having a unique hash key is a bad idea. But these also have to be made at table creation. There's also a hidden tax on this that it can never be more than 10 gigabytes. So a better hash key for our users would be, I mean, honestly, what sort of maybe if we're making a multi-tenant system, then their tenant ID. So maybe if we were going to recreate Blackboard, for example, our hash key could be the ID of OSU. It doesn't even have to be an ID. It doesn't have to be a number. It could just be the 3 letters OSU, and that could be our hash key. And then we can get all other students, all other things about OSU with a sort key or a partition key. And so then these local secondary indexes could be like grade or year graduating, whatever. Then you would have OSU and year graduating, and you could get all the students that are going to be graduating that year. And your local secondary index would be a maybe their major, for example. The problem with local secondary indexes is they can't have more than 10 gigs, and they can't have it's just a limitation on them. And so if you can think about a university that's been around like forever, like Princeton, like they possibly would need that index to be bigger than that if they want to keep all that data around historically. So local secondary indexes, just do not use them. But they come up on a lot of um, AWS examinations. I'm drawing a blank on what they're actually called right now. Certifications. There you go. They exist, but in practice, please don't use them. Global secondary indexes are amazing. They are great for using. You can add them at any time. You don't have to add them at table creation. They use a completely different table, technically, under the hood. So you have to tell Dynamo when you're querying a global secondary index which index you're using, because it actually has to query a completely different table because you're using a different hash key. And again, this goes back to Dynamo is just a like amazingly global distributed sub 10 millisecond query time uh, hash table. And so in this case, what we could do is with our multi-tenant Blackboard system is have our key of the 3 letters for the student or for the school ID, for example, and then we can create a global secondary index of maybe this, and this would be very bad because you get hot partitions, but for example, you could use uh, majors as your hash key and then the student ID as your partition key. So you would be able to use the hash key to get all CS majors and then the partition key to narrow it down to only user IDs that start with 1, 2, 3 for whatever reason. But you can add that at any time, and it is a completely different table technically, and that adds time to your eventual consistency or adds time to your uh, strong consistency because it has to write those to the other table. It has to write that to the index. Same thing as a SQL index, same thing as a NoSQL index. Um, but they get expensive. That is the downside to them, is that the two downsides are they increase your write amount of time because they have to propagate to the index, and they are expensive because they basically have to duplicate every piece of data that is um, in your primary table. Unless you make a sparse index, we may or may not get into that, but if it if you're interested, just Google DynamoDB sparse indexes. It's pretty, that stuff is incredible. Um, these help speed up queries. And like I said, with adding that secondary index, what we could have done is gone through and made two queries. We could have made a query on our original hash of OSU and then our partition key uh, of CS majors, and then taken all that data and then made another, filtered that on the client side maybe to get only the users with ID of 123. Um, but they speed up queries because they add another access pattern that we weren't using before. And they can save money because you're not overfetching. And in Dynamo, you're charged based on how much data you're reading and writing. Um, Mostly, that's how it happens. So in that last example I just gave, you don't have to overfetch a ton of the data that you're going to have because you made this second index. You can actually save a lot of money by not having to go to the database as much. Dynamo serverless, it's kind of just, I mean, it's a buzzwordy term to mean it's a proprietary database that you can't take anywhere else, but it's managed for you, which is nice. It's fully managed service, and the the they tout that there's no realistic storage limits, and it's probably true. I mean, your application, my application, is never going to reach the amount of stress that Dynamo needs to be able to endure on Black Friday or Cyber Monday on Amazon.com. Like it's just there's no realistic storage limits that you ever have to worry about. Um, it's highly available, replicated across 3 availability zones by default. So like you don't have to do anything to get this to happen. This is again also why you can either pay more to have this data be strongly consistent, or um, pay less to have it be eventually consistent, because it's going to be replicated across these 3 availability zones. It always will be. And so you can either, again, pay more to wait for that to happen, or pay less to just assume that the distributed system that Amazon has created to do this will do it within that 1 second. Performance is easily anticipated. There's an amazing graph, maybe I'll try to find it, that shows kind of just an approximation of DynamoDB versus like a MySQL, not sharded, like probably actually a pretty, just a standard MySQL install. And the MySQL install is actually, when the data is really small, is actually faster than Dynamo. But DynamoDB is very like just sub 10 millisecond queries. That's kind of like what they're doing. And as as the data increases, because it's again just a hash table, that that's still just an O of 1 lookup. Like you all know this, it's not going to be dramatically more or less because of how the system has been created. Meanwhile, because SQL indexes or SQL engines, excuse me, have to basically have an nlogn sort for a lot of queries that are, even if those queries are optimized, they're going to go up as your data increases. Like it's just that's how things work. So performance being easily anticipated, you know you're going to get the same performance no matter what scale it is pretty rad. And you can tell Dynamo how much to actually allocate for your read capacity and write capacity as well. There's auto scaling, which is neat. It's a Unfortunately, auto scaling is a pretty boring topic now. Like all of these cloud providers auto scale to, quote unquote infinity and scale back down. Um, but there is a really neat feature that you can have on demand capacity now. You used to not be able to. You used to always have to tell Dynamo that I have this many write capacity units and this many read capacity units. But now you can actually just say, give me all of them when I need them, and I'll, just charge me extra for that. And this is kind of a this is kind of a piece that's true for all technologies. But if you hear horror stories about like, DynamoDB doesn't work or DynamoDB doesn't fit my use case, like they're still usually from people that don't actually understand the tool. And insert DynamoDB for anything. Um, but it's definitely, you want to understand what DynamoDB is good for and what it's not good for, honestly. Like we've talked about that it's really bad for like OLAP analytics. Like you're not going to run a BI engine on Dynamo. Like it's silly. So you want to understand the tools that you're using is kind of what I'm getting at. Dynamo's pricing model is really strange to get used to, but once you get used to it, it makes a little more sense. Storage is cheap. Again, like that's kind of something I want you to take away from this class. You probably already knew it, but storage is going to be your cheapest part of Dynamo. For example, your throughput is what is actually going to cost more and what you have to optimize for when you're optimizing for cost. And these come in the form of read and write capacity units. So a write capacity unit is equal to 1 kilobyte per second. So if you needed 2 writes, it would be 2 times 1 kilobyte per second. So you'd need 2 write capacity units. A read capacity unit is 4 kilobytes per second. So you can read up to 4 kilobytes per second with 1 read capacity unit. And then you can divide it by 2 if it's eventually consistent. So you would need 1 read capacity unit if you're going to read 4 kilobytes. You're going to need 1 write capacity unit if you're going to write 1 kilobyte. And what that means, and what we've been kind of saying, is that reading data is a much more common act than on really any piece of software. But writing is going to be your more expensive action. And that divided by 2 if eventually consistent means that you can write up to 8 kilobytes per second for 1 read capacity unit if it's eventually consistent. I hope that can kind of sink in. If you're using strong consistency, then you can only read 4 kilobytes. But if you're eventually consistent, you can read up to 8 with 1 read capacity unit. And a form of this is going to be on your final. Like, again, just good to know. On-demand capacity though gets rid of all this. Like you don't need to care about this. The reason you do want to know about these though, read and write capacity units, is if you have an app that is consistently at any level, doesn't really matter. If you can dedicate resources to actually planning these, then it's significantly cheaper than just using on-demand capacity. On-demand capacity is a trap. Like it very, very much is. It's a it's a great way to get started, but just be careful. And again, the big secret is that DynamoDB is just a hash table. It's basically a hash table. So the way I want to also emphasize this is that you can think of your hash key as the hash key. I mean, it's a great way to think about it. But then your range key is how DynamoDB reconciles collisions for hash keys. And so all of you should know what I'm talking about with this. When you created your hash keys in probably C and it was terrible, that you had to create a way to reconcile hash key collisions. And so you probably made a linked list. And so it's not one-to-one with actually how Dynamo's implemented this, obviously, because I mean that would be very slow. But you can think of it as if you're going to be in this slice of this hash key, and again, like that hash key in the example we were just talking about was the letters OSU. So that hash key has a lot of collisions, quote unquote collisions, and that can be literally everything in the university, like it can be, in our example, it's going to be students. So all the students and their majors are going to be how Dynamo would resolve those hash key collisions of so many records with the three letters OSU. DynamoDB don'ts. Avoid scan operations. And so what this means is that you have to actually say that you want to scan. So you want to avoid scanning the entire database when possible. And that's easy to say and kind of easy to do. Um, but it's just always important to think about. If you scan that whole database, it means you're going to look at literally everything that is in that whole database. Um, Avoid joins at the application layer. And so this is kind of what I was talking about with faux SQL, is that if you're if you have multiple tables and you're joining all that data in your application, you're going to do that slower than a SQL engine would just making a join. So it's not really the way you should be using this tool. Keep your things in one table and be able to query them based on different, either different keys, like you can have a GSI, you can have a different index, you can have them in a kind of more clever way that we're going to get into. But please avoid joining at the application layer. And just don't make your hash key unique. It just defeats the purpose of a more wide column store uh, like Dynamo or Cassandra that it just turns it into a distributed, more expensive Redis. Um, so use these as like hash keys for a hash table, and use your partition key as a partition or sort, same thing, as the way to reconcile those or create what's called collection group queries. And we'll get into that in the code. But don't make your hash for partition key unique. Then it just kind of loses all purpose. Do use indexes whenever you have to. Use global secondary indexes, they're neat. Don't use local secondary indexes, but those just allow you to create different access patterns. And that brings me to the next point, is that you really need to plan your access patterns. You can't just, um, it's really hard for a startup to just use Dynamo right off the bat. Um, it's not to say it's impossible. You absolutely can. There are thousands of successful startups using DynamoDB, but you have to really plan how you're going to use it, or you're going to just keep rewriting a lot of how you get your data. Make your uh, combination of hash and partition key and sort and range key unique. Again, this is how you're going to unlock a lot of the potential of Dynamo.